Now we can start talking about Newton's first law of motion. Now consider two objects. One of the objects is at rest, just like this rock. Second object is set into motion by, of course, applying some force, pushing it with some force, but then force is removed. And after the contact is removed, if the force is removed, still it moves. It's in motion. In the absence of a net external force on an object. So Newton's first law is talking about this. In the absence of net external force act on an object, which means net force acting on an object is equal to 0. Two possibilities you can observe. One of them is, if object is initially at rest, just like this rock, it will continue staying at rest. And this rock will stay there till the end of the universe. If no external force acts on it, it will stay like that. Second one is, if initially you set this puck into motion, if net external force acting on the puck becomes 0, this puck will continue moving with constant velocity. So while second object will continue with constant velocity, it will move. As a result, Newton's first law states that unless the objects experience a net external force, yani net external force acting on the object is 0, object stay at rest if it is initially at rest, and object at rest will remain at rest. But object, if initially in motion, it will continue its motion with constant velocity, which means constant velocity in a straight line path with constant speed. This is a misconception. Every time a student thinks that if the force acting on the object is 0, object must stay at rest. No. Initially, you can apply some force on an object. You can set this object into motion, but then you can remove the force. Then it can continue in motion, even if no force acts on it in the direction of motion, as you see. So this is also a part of the Newton's first law of motion. Object in motion continues in motion, stays in motion, but with constant velocity, equal speed, constant speed, but in a straight line path. So, in the absence of net external force, object's nature is to maintain its state of motion. This rock is at rest. If when you apply some force, it resists to move. Or, if object is in motion, if you want to stop this object by applying some force, it resists to stop. So, resist to change in velocity, this one. Basically, if two things are combined, we can say that natural tendency of an object is resist to accelerate, because if object is at rest, if you want it to move, you should accelerate it. If object is in motion, if you want to slow down it and stop it, there's an acceleration. So object's nature is always to resist to acceleration. Object does not want to accelerate. So in other words, tendency of an object is not to accelerate. And this tendency of an object not to accelerate in physics is named as inertia. Inertia is tendency of an object not to accelerate. So object wants to stay at rest if it is initially at rest. If you want to move it, it resists. If object is in motion, it wants to continue moving. If you want to stop it, it resists. This resistance, this opposition in physics is known as inertia. That's why inertia is above Newton's first law. So object's tendency to keep its state. That's why sometimes Newton's first law of motion is named as the law of inertia. Newton's first law, often referred as law of inertia, because it states that in the absence of a net force, a body will preserve its state of motion. If it is at rest, it will stay at rest. It wants to stay at rest. If it is in motion, it wants to be in motion with constant velocity. And think two balls. One ball is the bowling ball. Second one is the basketball. So what is the difference between these two balls? You can easily get it. Of course, bowling ball has a greater mass than basketball. Greater mass bowling ball, smaller mass basketball. Okay. Imagine, these balls both are at rest, and you apply equal forces on these balls. Which one is harder to start motion? What do you think? Everybody can predict it. Of course, it is harder to start motion of the bowling ball because it is a greater mass. Resistance to accelerate is called inertia. So bowling ball resists to accelerate, which means bowling ball has a greater inertia. Then we can say that if an object has a greater mass, it has a greater inertia. Bowling ball will resist to accelerate more than basketball. That's why we can say that bowling ball has a greater inertia. The greater the mass of a body, the greater the inertia of that body. For that, as in physics, it is written that mass is a measure of inertia of an object. How big the inertia of an object is, so mass of that object is also big. Or inertia is proportional to mass of an object. If the mass is greater, inertia of an object is greater. Okay, this is all for this part. We will continue the next title, equilibrium, which is also a consequence of Newton's first law of motion.